In this video we will talk about sizing and positioning. And before I start, I want to put logic of a view of widgets to a markup file. For markup files, Kivy uses files with the Kivy extension. If we will look in the app class source code, we will see that the run method firstly loads a config file and secondly loads the Kivy file with the load Kivy function. If we will look at the load Kivy method source code, we will see that by default Kivy will search for Kivy file with the name of our application without the last three letters, that is, without the app suffix. In my case, the Kivy file should be my Kivy, so I'm creating it, my Kivy. And I'm creating a new class. Let's say it will be container that will inherit its properties from the box layout class. The build method of my app class will return an instance of the container class. So return. And in the my Kivy file, I'm starting to build a tree of widgets. And inside the angle brackets, I'm putting the container. Angle brackets mean that I'm defining the rule of view of my class, the container class. Here inside button text equals to hello world, and another button text equals to, let's say, new button. And my container class is a subclass of the box layout class that uses horizontal orientation by default. I want to use vertical orientation, so in the top level orientation property will be equal to vertical. Let's check it. Our two buttons. Okay, I want to have paddings and spacing. So here padding property equals to 50 pixels. I've got paddings. Paddings are the space between the inner border of a layout and the button widget. For instance, if you go to the bookcase and open its door, the space between the wall and the bookcase is a margin, and the space between a wall of the bookcase to its content to its books is a padding. So I have padding here, and I want to increase the space between buttons. So spacing equals to 50 pixels too. Something like this. But each time to run the code is not a convenient way to look at your work, and Kivy developers provide us with a small lifehack. Let's install Kivy examples package. Sudo Kivy examples. I always forget where it is installed, and to know it I use where is Kivy examples. I need this directory, Ctrl-Shift-C. Change directory And here I need a demo folder, cd demo, and I need KivyCatalog, main py, Python 3, main py. Okay. This is the KivyCatalog. We can play with these widgets, and also we can write a code. For example, let's delete it and box layout, button, the code updates are displayed automatically, but with a delay. But if I press the Ctrl+S hotkey, as if I wanted to save a document, the changes will be displayed almost immediately. It is very convenient for experiments. For instance, let's say padding 15, spacing 15, Ctrl+S, orientation vertical. Sorry. Okay, let's talk about widgets sizing. Widget size is determined by the size and the size hint properties. The size is a tuple that specifies a widget's size in pixels. That is mean that the widget becomes fixed sized. The size hint property determines a widget size as a percentage of space provided by its parent container. The size hint property is specified in values from 0 to 1. 1 means 100%. And by default, the size hint is set to 1, 1. That is mean that a widget by default takes 100% horizontally and 100% vertically. These two properties are opposite to each other. We have to set a widget size either by using the size property or by using the size hint property. And the size hint property always has priority. It means that if I want to use the size property, I have to set the size hint property to none, none explicitly. It looks like this. For example, I want to have the first button size equals to 100 pixels, and we can see that nothing changed. To make the size property work, I have to set the size hint property to none, none. Size hint none, none, Ctrl+S. And the first button became smaller, and this button has a fixed size. And I believe that it is necessary to use the size hint property and proportional dimensions to make interface look the same on any device. But there is an important detail. Different layouts can size widgets in different ways. Let's remove the padding property, the spacing property, also the size hint will be 1, 1 as the default values. The current box layout, when is vertically oriented, takes under control the vertical size of its children. By default, the box layout widget calculates its space between its children evenly. That is why our buttons are the same size right now. And as the vertically oriented box layout takes under control the height of its children, we cannot determine the height in a natural way. We can set only width of its children. For example, let's say button 1 will have 0.5 width and 1 height. Everything is alright. We got the button with 50% width. But if I set the height to 0.5, we will get a very weird result. The height of the button is not 50%, it is 33%. Why so? In this case, the size of the button is calculated with another formula. The formula is the size hint of the first child, I set it to 0.5, is divided to the size hint of the first plus the size hint of the second child. That is 0.5 plus 1, and we got 33%. And what we have to do with it? The answer is don't fight with a framework. In this case it means that if the vertical box layout controls the height of its children, we should use other ways to set the child widget's height. To use the padding, the spacing properties, or even to use other layouts or maybe a combination of layouts. When a box layout is horizontally oriented, we can determine only height of its children widgets, but not width. And now let's talk about widgets positioning. The position of a widget on a layout is determined by pose and pose hint properties. These properties, by their idea, are the same as the size and the size hint properties. The pose property determines coordinates of a widget in pixels. For the sake of demonstration, I will use the float layout widget. It allows to place widgets freely as we like. So here will be float layout. By default, our buttons took all free space and are placed one under the other. Firstly, for the first button, I am setting the size to 30% width and height. Let's 30%. And the second button, size hint to, let's say, 20%. Okay, now we can distinguish both buttons. The pose property is determining the place on the float layout in pixels. The point with 0, 0 coordinates is the left bottom corner. Here, left bottom corner. Let's set the pose property of the first button to 100, 100. Pose. And the second button 400 and 100. Okay, it's working, but we need adaptive UI. Fixed position. I want to have adaptive UI, so I have to use the pose hint property that determines a widget's position inside its parent container in percents from 0 to 1, where 1 is 100%. The pose hint property is a dictionary. Size hint is a tuple, size and pose also tuples, but pose hint property is a dictionary. And I have made a small presentation with the keys of the pose hint dictionary. X-axis. The left edge is X, the middle center X, and the right edge is the right key. Y-axis. The bottom is Y, the middle center Y, and the top edge is the top key. And the values of these keys are values from 0 to 1. For example, let's align the small button by a center. Pose hint, center X to 0.5 and center Y to 0.5. I forgot the quotation mark. Okay. The small button is centered. And I want to push the big button to the top edge. So, pose hint, the center X to 0.5, top to 100. Top 1 means that the top edge of the button is located at 100% of height of the button container. And as the pose hint is a dictionary, there is no difference in which order to set the keys. It was basic things, and behavior of layouts is different. To know what properties we can set, we have to check the official documentation. The next video will be about sending data from the app's GUI to the Python script and vice versa. Thanks for watching, please like the video and subscribe to the channel.